Hi. Hello, everyone. My name is Mark. I'm a postdoc at Oxford, but I was formerly here at Leeds University. Today I'm going to talk a bit about how global data might be used to calculate flood exposure to refugee camps in Ethiopia. And although I'm up here giving this presentation, this work really began as a master's thesis by Faye Blanken, who's sitting over there. So since her graduation, we've been working together to develop this research into a paper. So a lot of the work I'll be presenting here is also Faye's work. So I'll start by putting the project into context a bit. So as of June this year, there were nearly 90 million forcibly displaced people globally. Over 30% of these were refugees. So climate change is expected to be one of the key drivers of future forced migration, as the increased frequency and severity of extreme events makes regions less hospitable, and increased competition for scarce resources in some regions becomes a greater catalyst for future conflict. So by 2050, estimates range between 200 million and over 1 billion climate displaced people. So this is a big problem that's only going to get bigger in the future. And refugees represent one of the most vulnerable groups to climate hazards such as flooding. Over half of the world's refugee population is children. They typically live in developing countries, and they often lack proper housing, healthcare, and access to clean drinking water. Refugee camps, which house 20% of all refugees globally, are also incredibly vulnerable to the impacts of flooding. They're typically located near watercourses because they need access to fresh water, which increases their exposure to flooding. They're typically located in remote locations with limited access to roads and infrastructure, which makes relief efforts post-disaster difficult. And the shelters which house the refugees within the camps are typically built out of simple materials which aren't built to withstand flooding. So to properly manage the risk of refugee camps, it's important to understand which camps are exposed and how exposed they are. But the problem is that many of these camps are located in regions with no existing local flood risk information. So global data sets could be useful for filling these data gaps and help us better understand camp flood exposure. So that's the sort of aim of this study, to explore how global data might be used in this case, what the sort of limitations are of global data when used in this context, and also how we might incorporate local data to enhance the analysis. So we use Ethiopia as a test case for our study. So there were a number of reasons why we chose to do this study in Ethiopia. Firstly, it has the third largest refugee population in Africa. Nearly 900,000 refugees are housed from surrounding South Sudan, Somalia, and Eritrea. And most of these refugees live in 24 camps throughout the country. And these camps have a history of flooding in Ethiopia, which shows that it's important to understand the exposure of these camps. So this figure, or this image on the bottom of the slide, shows the aftermaths of a flood event in 2014 in the Gambela region of Ethiopia, which actually led to the closure of a refugee camp and the relocation of those refugees. And finally, we've done past research in Ethiopia through the Water Security and Sustainable Development Hub with partners out in Ethiopia, looking at the usefulness of global data used in a national context there. So this work really builds on that previous research. So I'll start by highlighting a few key challenges with using global flood risk data in this context. Well, firstly, these camps and their populations are incredibly dynamic. So this graph here shows how camp populations have changed since the beginning of 2018. And these two green lines represent the camp populations in Ethiopia when Faye first started looking at this work for her master's thesis, and what the camp populations are now. So throughout this project, we've had to regularly update the population figures we're working with, because so that we're using the most up-to-date ones. And during this project, one of the camps we were looking at was actually destroyed in the Tigray region of Ethiopia because of the conflict that broke out there at the end of 2020. So global population maps, which are typically used to calculate exposure, they're built using historic census data and historic satellite data, which can't really capture the dynamic nature of these camps and their populations. The second challenge is to do with the size of the camps and the sort of granularity of the required from the data to represent them properly. So the camps in Ethiopia range in size from 1 square kilometer to 9 square kilometers. And on the slide here, you can see the medium-sized camp of Hugo at roughly 3 square kilometers. And on the bottom of the slide here, you can see the different grid resolutions of global data sets. So you can see that global population maps and global flood maps at 1 kilometer resolution are really going to be too coarse to properly assess the flood exposure of these camps. You need to be pushing towards the 90-meter and 30-meter resolutions to begin operating at the precision necessary at these scales. But just because a data set's precise does not necessarily mean it's accurate. The third challenge is these camps are typically located in rural areas. So here's a simple proximity analysis of each camp's closest urban center. So on average, we found that the camps are located roughly 30 kilometers from the nearest urban area. And a lot of previous research has shown that global population maps are pretty inaccurate in rural areas. So this is another challenge. The final challenge is related to the size of rivers most of these camps are exposed to, which limits the global flood models that can be used in any such analysis. So only 3 of the 24 camps in Ethiopia are exposed to flooding from large rivers with an upstream drainage area of 5,000 kilometers squared or greater. The remaining exposed camps are exposed to flooding in small rivers with an upstream drainage area of 500 kilometers squared or below. So this sort of limits the global flood models that we can use. So we use only the Fathom global flood maps. We use both their fluvial and pluvial flood maps, which captures inundation on quite small streams. So now to begin taking you through our methodology quickly. So we split our methodology into 3 stages. We began by mapping the camps. We then evaluated the global population maps, and then based on this, we carried out a flood exposure analysis. So to map the camps, we got point data on camp locations from the UNHCR, and also we scoured the latest UNHCR camp reports to find the latest camp populations. Because we only had point data and we didn't have any information on the geospatial boundaries of these camps, we had to produce these ourselves. So OpenStreetMap did have some camp boundaries, but the rest we produced manually using satellite data from multiple sources. Where building footprint data was available, we included this as well to get an idea of where the structures were located within the camp. So we used both OpenStreetMap data and Google Open Buildings data. And the coverage was fairly good. So in 21 out of 24 camps, we had footprint data from at least one of the 2 sources. And in 16 of the camps, we actually had footprint data from both sources. So this is what a final map camp looked like. You have the sort of camp boundary, the building footprint data within the camp, and what we found was the latest UNHCR camp population. So the second stage was an evaluation of the global population data. So the question we were trying to answer was, how good are these global population maps at identifying camps and replicating camp populations? So to do this, we compared 5 commonly used global population maps with the UNHCR reported camp populations. And based on the results of this evaluation, we then used the best performing global population map in our exposure analysis. So the final stage was the flood exposure analysis. We took 3 approaches to calculating flood exposure. The first was a traditional approach using global data sets, so where we just intersected a global flood map with a global population map. In the second approach, we assumed that the UNHCR camp population was distributed evenly across the camp area. And in the third approach, we distributed the population data across the building footprint data. And the neat thing is when you compare the second and third approach, you can get an idea of whether the internal structure of this camp or these camps are set up in such a way to reduce the exposure of flooding, because you're essentially comparing an approach where no consideration has been made for the location of structures with how the camps are actually set up. So just to begin taking you through some of our results, starting with the evaluation of the global population maps. Well, in short, global population maps do a pretty poor job at representing these camps. So in this figure here, for each of the 24 camps, this horizontal blue line is the UNHCR reported camp population. And these colored points are the camp estimates from each of the 5 global population maps. So you can see that for the most part, global population maps are significantly underestimating camp populations. So the 2 worst performing data sets were the global human settlement population layer, which predicted 0 population in 19 out of the 24 camps, probably because it was developed to map urban settlements. And the other worst performing data set was the World Pop Unconstrained map, which regularly predicted camp populations in the low hundreds. The best performing global population map was Facebook's high resolution settlement layer. Best is putting it probably incorrectly. The least worst data set was Facebook's data. So it regularly predicted, or on average, it predicted about half of each camp's population. So these sort of results suggest that global population maps probably aren't suited to the task of calculating camp flood exposure. So moving on to the flood exposure results, you'll recall from a few slides back that we took 3 approaches to calculate flood exposure. The first was using a global population map, which in this case was the best performing Facebook data. We then also did the approach where camp population was distributed evenly across the area and then also across the building footprint data. Well, as you might expect from the results on the previous slide, even the best performing global population map really misrepresents how exposed these camps are to flooding. So if we look at the total average annual exposure calculated using the Facebook data, it's about 1/3 of the total average annual exposure calculated using the other 2 approaches. And if you look at this figure here, the sort of overall picture of which camps are most exposed changes completely when you're using the global population maps. And worryingly, it's really underrepresenting the flood exposure of the 2 most exposed camps in Ethiopia. On a more positive note, if we compare the 2 approaches using the UNHCR data, we find that for the most part, these camps are set up internally in such a way to reduce the exposure of flooding. So this bar chart on the bottom shows the percentage change in exposure when we incorporate the building footprint data compared with just distributing the population across the camp area. So we can see that in all but 2 camps in Ethiopia, flood exposure is actually decreasing. So just to zoom in on the 2 camps with the biggest exposure decrease, you can see that the majority of structures are located outside the flood extent. And this was the case for most of the camps where exposure decreased. Looking, on the other hand, at the 2 camps where exposure increased, you can see that the flood extents here are much larger and a larger proportion of the buildings are inundated. But interestingly, much of the extra inundation is coming from rarer, higher return period flood events, so 50 years or greater, which suggests perhaps there hasn't been a flood of this magnitude in recent living memory in the region, which could help inform the sort of setup of the camp. So that was just a brief overview of where we are in the analysis right now, just to highlight some of the key findings and conclusions. Well, firstly, the global population data isn't really suitable for representing or understanding refugee camps in Ethiopia. Most data sets can't represent them properly, and they aren't appropriate to be used in any exposure analysis. Similarly, many of the global flood models don't model flooding on the rivers that these camps are exposed to, which makes the choice of model incredibly important when used in this context. And what this means for traditional national flood risk assessments using these global data sets is that they're underestimating exposure by quite a bit. So to put some figures to this, for the 100-year flood in Ethiopia, you're underestimating flood exposure by between 130,000 and 190,000. But this doesn't have to be the case. There's a wealth of locally available data from the UNHCR and other resources which can easily be incorporated into such assessments and dramatically improves the accuracy. And this can lead to some interesting results, like we found for Ethiopia, that for the most part, these camps are set up in such a way to reduce the exposure for inhabitants. So what are the next steps for this analysis? So this presentation only really covered flood exposure. We didn't look at risk. So we're currently working at incorporating some measures of vulnerability to begin looking at the risk of these camps. We also want to expand this globally. So this study only really covered less than a fifth of the global refugee camp population. So it's been nice here at the GFP to link up with Hannah, who's done a lot of work on these sort of things in Uganda. So hopefully watch this space as we sort of expand this analysis. And finally, many of these camps are located in regions that will really bear the brunt of climate change and its impact. So we'd like to incorporate a sort of forward-looking analysis in the future to look at how flood risk to these camps might change due to climate change. All right, that's everything.
So that was really nice stuff. Very good. A quick question. These are behind time, but one question if there is.
I have a quick one.
Yeah.
So the resolution of the flood simulation seems fairly coarse for that the size of the.
Yeah, I think we're definitely sort of pushing the limits of what's possible with these global data sets. But now it'll be interesting to incorporate the new Fathom maps when they're available 3.0. We'll see maybe the 30-meter resolution will improve such assessments. But I guess when we were sort of discussing this, it's like I guess some information is better than no information, and you can sort of get an idea of the rough exposure of these camps, even using 90-meter data.
Very good. Thanks, Mark, again.